So what is triage and why do we do it at the Adoptium project? Well, triage is about sorting and categorizing and prioritizing problems as they arise. So we do this at the project because we run a lot of testing and test cases fail. We have to identify whether these failures are actually real product defects or are they an indicator that there's a test case problem or an infrastructure problem. We have to make quick decisions. We have to try to determine root cause quickly, and if we can't determine root cause, at least get to the point where we've categorized things into three broad categories: a product problem, a test problem, or an infrastructure problem. So the product problem is the high priority item. If there is a defect in the product code that we're testing, we want to identify that quickly, and then we're going to have to figure out what kind of impact or risk that has to our consumers. If it's a test or infrastructure problem, while those can be hiding product problems, if they happen, we might not see other issues. Those are less lesser priority than a product problem, and typically those would go below fixing of the product problem. So when we're in the middle of a release period and we're doing triage, we're trying to determine impact and make an informed decision on whether a test case failure that we're seeing in a particular run should block the release, and it's a no-go, we can't deliver a platform, or it's considered non-blocking. And that determination is not necessarily straightforward, and that's typically done by a PMC member or members of the PMC. This little diagram here shows some of the ways that we could try to determine and categorize issues. You can find this in our documentation. We're going to be taking a look, a very high-level look at January and April 2024 CPU release and the kind of triage that we would do at the project for those releases. But before we kind of dig into that, the general idea here is that when we build a particular Temurin binary for a certain version and platform, that tarball that's created has a smoke test that is run against it that determines, well, are all the features that we expected to be there present? If so, we can proceed to running the quality tests that are part of the AQAvit suite and the compliance tests, which are provided through the OCTLA. So you can see that there's a lot of testing that gets triggered all at once when we get to the point where the smoke test has passed. It's triggered ahead of some of the other activities in the build pipeline. Some of this testing can take hours and hours to run, so it runs in parallel, and a few other activities happen while all of this is running. Just to get an idea then of that particular, what that was, the diagram on the previous slide was representing one single product, and for the January CPU, we delivered 41 products. So multiply that diagram of the several hundred thousands of test cases running times 41 products. So that's JDK 8, 11, 17, and 21 for January. And for April, of course, we see an additional version happen. So we now have 4 LTS releases and the JDK 22 pipeline. Each one of those releases have 10 or 11 platforms covered under them that we deliver. So all this to say, it's a lot of things to look at. All right, a little bit of very quick terminology. You can come back to this slide when you're actually doing triage for us. That's the intent of this lightning talk. There is this notion of a grid of tests. We use this visualization, the grid view, to be able to look at a lot of tests in a small space of the GUI in the test results summary service. Columns are the groups that we identify, and those are really related to what the tests either do or where they come from. So OpenJDK group are the tests that come from the upstream OpenJDK project and or are destined to be pushed up to the OpenJDK project. Perf is performance benchmark. System tests are broader integration tests and or load and stress tests. JCK represents the compliance suite that comes under the OCTLA. And in our TRSS instance that is public, we don't monitor our private server that runs these tests because we are not to share those results in detail publicly. Some of the terminology here, each one of those little chiclets in that grid view, the little squares, green, yellow, red, and gray, represent a top-level target. So they're a group of test targets, and many test targets that are tagged as being of a certain level and a certain group. So sanity.openjdk is one of those chiclets. Taking a specific example, Sanity OpenJDK at the moment is equivalent to Tier 1 testing from the OpenJDK project, and it contains test targets like JDK Math. Within JDK Math, and that's quite a small test target. From there's around 41 different test cases, one of them being big integer test. Some of these chiclets represent not just hundreds of tests, but thousands of tests, depending on the group and the level. All right, so you can see the pipeline states, the green, red, yellow, and gray mirror the same colors and states that you would see in a Jenkins build. So just as a reference, the green we can ignore during a release because that indicates all tests were run and all tests pass. Yellow needs investigation because that means the pipeline was able to complete, but there were some test cases failing. Red is a problem because it means the pipeline was not able to complete. It often indicates an infrastructure failure. And gray means the pipeline was aborted, which can indicate that someone manually aborted it, but often indicates that it hit a time limit by which it should have finished and it did not. All right, so when we triage during a release, we actually identify which release pipelines we're looking at. Those are announced in the release Slack channel and also are linked in the status issue that we raised to cover the status of all releases happening during a particular CPU or feature release. We can navigate to those release pipelines in TRSS. How does that look like? Well, we go to the TRSS server, the test results summary service. We find a particular release. We look for that build ID that it matches. We also can check the date to see, oh yes, that is the one that is launched as part of this release. And then we can click on that grid view to see where we're at in terms of what test pipelines have already been run and completed. And once they start to complete, we can begin our work triaging the release. So we'll head into a little bit of a demo now and show what some of the activities are that we do during the release. All right, so we've popped over to the release checklist for April 2024. and kind of scrolled down to find that the release pipelines have been launched, and to also look at what their numbers are. So we're going to navigate now to the TRSS server. And again, those quick links directly to these release pipelines in the server are up at the top of the Slack channel, the release channel in Slack. But I'm just going to navigate directly from the main page of the instance. Takes a little longer to load, but you can kind of see the amount of pipelines and testing that we're running. So let's take a look at an example here of the release for JDK, the pipeline for JDK 17. So we know it was pipeline number 62, and this would be this one. And we can see already a quick summary here that we've got some test targets that are failing, a lot that we're passing, and hopefully we won't have a whole lot of work to do triage. But this number indicates that there will be some work. So we'll click onto that grid view, and it's essentially going to show us all of the different platforms that were launched as part of the JDK 17 release pipeline. And I can immediately say triage is complete for ARH64 Linux. All the top level test targets that were run as part of this release are green. There are no test failures, so that's an immediate thumbs up. And we're going to go over to the status issue now and say, oh, great, for JDK 17, we're looking at this after the release is complete. But what would happen would be that ARH64 Linux says, good, the triage for the Aqua testing is done. We're good to go here. Check mark into this box. Up until we do that, there is a little icon that says we are in the process of working on this, or we haven't started this. So we come back to the test results. We can also say we're good to go on ARH64 Mac. But we come into some of these other platforms and we have some failings. And as we know from the terminology, green means the pipeline completed and all test cases passed. Yellow means the pipeline completed, but there were some failures, test case failures. Because ARM Linux and AIX and PPC64, all these ones are secondary platforms. We're not going to focus on those. We're going to look at the primary platforms first, which are listed here at the bottom. Good. Another primary platform is marked ready to go. So of this list, we're going to see that the primary platforms, which are here, the top two there, and the bottom three of the 5 are already ready to go. They're all green. We're good. x64 Linux now seems to have some issues. The top level target extended OpenJDK has some failures, as well as extended system. You'll also see an indicator here, a little circle with an I in the middle, saying that because the first run failed or had some failures, we tried to automatically rerun those failed test targets, and not all of them passed at that point either. So we're going to click into extended OpenJDK for 64-bit Linux, x64 Linux. And we see that there was a single test target that failed, and it failed on this machine. And if I clicked on this link here, I would see the console output from that test. All right, so we've taken a look at the fact that we had a single test target failing. We're we would check, we could check, was this test target failing on any other platforms as part of this release? It did fail on AIX here, but there doesn't seem to be a pattern that it's not failing on a particular architecture or all Linuxes. So we'll move back to the set of action buttons here. I'm interested to see what deep history tells me. It does tell me that it seems to be mostly passing, but it failed on this machine. And this machine, I don't see any other cases where we are running on this machine. So it might be a machine issue, still unclear. But now we know where it is passing and where it is not. So when we do a rerun, we may try running it elsewhere, and we may suspect this is a machine issue already. All right. We can check whether or not there is already an issue raised in any of our repos at the project. I have already checked, and I know there are not, so I won't bring that up. But if there were, it would try to list them, and then I could determine, yes, I think this is the same issue, and I could update that issue with some more information. Since I know there's not an issue, I could create a new issue. And what really this does is just pre-populate an issue with some information, gives me a rerun in Grinder link. I may grab this machine name and say, let me try to rerun this immediately. And I want to rerun it on that machine, so I'm going to change the label to be the host name of the machine I want to run on. And then I'm going to hit build. All right. So that's the create new issue button. We can then transfer the issue to the appropriate repo after we determine if it's an infrastructure, a test, or a product problem. I may also want to go directly to the Jenkins job so that I could see of that one single test target. Remember, test targets contain many test cases. I actually can see that the test of the 2,302 test cases in that test target, only one is failing. And I can take a look at how it's failing. Oh, and I see it's an out-of-memory error on that single machine. So we're starting to learn more about this failure and suspecting it's possibly a machine issue. All right. We come back at this. Again, I can get directly to the rerun and Grinder link from here, just as we'd already shown. But I do want to go back now, or I do want to say that I know that this test was automatically rerun for me, so maybe I don't even need to run a Grinder. I want to see that same test target. Ooh, and there it is, the instance of the rerun of that exact same test target that failed. We automatically reran it. And it happened to rerun on this machine, which is different than this one, and it did pass. So this saves me having to launch a Grinder myself, but I still may need to make a few notes and raise an issue to investigate if this is a singular machine problem or not. But at this point, I'm suspecting it's a machine issue, and I'll make a note in my triage issue that got raised in the AQUAtest repo to say, okay, I think this is not a blocking test. Here are all the information that I have about it. I was able to see that the rerun passed, and I'm not thinking this is something we're going to block on. Okay, so we're looking at this grid view, but one of the very first things we would normally do would be actually to generate the release summary report. And the reason we do that is actually to populate our triage issue. And the reason we populate a triage issue, and I'll find the one for 17, here it is in the AQUAtest repo, is so that we can work together on triage. we have a table up at the top of the issue that says, okay, here are all the platforms that are being considered as part of the JDK 17 April 2024 CPU release. We had seen that some of them have already immediately passed, so we can mark them with a check mark. That means no one else who's looking at this issue needs to go off and do anything more about them. For anything, and we were looking at the 64-bit Linux one, for anything that was actually showed that it had some problems to look at, we would create a comment and we would gather the information from that release report and plunk it in here and then make notes as we worked. So I looked at this during the April release. I gathered this, I copy pasted the items from the release summary report to put over into my triage report, and then I started making notes. As I also said, the action to take away from this is that it failed in the original run, or there were things that failed in the original run and passed on other machines. So we need to take an action to raise an issue. In this case, this note is actually related to, if I go back here and we're looking at that same platform, we're looking at this other one, the extended system failure, and I had this test target in its two modes, a non-compressed ref and compressed ref, both running on this same machine and both failing. But when I search here for HCR and I see those same ones automatically were rerun, and they were rerun on this machine, they both passed. So that again indicates to me that there's likely some issue. I'd like to see what this failure was. These system tests have often a lot of output, so it's not always obvious in what way they failed or why they failed. But we grab that output and we create an issue for it. I also do want to see this in deep history to say, is there a pattern where it's actually failing? Well, it's almost completely passing everywhere, but it does seem to fail a couple of times in deep history, and maybe it's on particular machine or machines of a particular common configuration. So we see it on the IBM Cloud Rail 6 machine, the failure, and also on the Ubuntu 2020-204 machine. So, and again, this one doesn't indicate a great amount of information or pattern, but maybe we can make some sense of it. We definitely should capture it in an issue. All right, we were going to take a look at some of the examples of what if the rerun did not pass. Let's see. If I'm looking at one of these examples and I say, okay, let me go take a look at S39EX Linux. Some of the failures that were for this platform, there's a few. And I can kind of see, there seems to be a lot more than I like the look of. I know I've had, in the dry run, we've encountered some machines that have problems with host name configuration on them. So when I see a giant number like this, I'm going to suspect that's what's happening already, because I am aware that we've had that problem before. And in fact, yes, I believe that is the case. And we can already see from the output that comes with the release summary that mostly if you look at these numbers, these targets are passing a lot of the time, but failing a portion of the time as well. So we could go take a look at those. And again, here for the sanity system failures, looks like often passing but sometimes failing. And as part of looking at the results of these, we see, yes, on certain systems, we're getting that no route to host exception, um, which is an indicator that this is an infra problem. The automatic rerun of that same top level target passed. So clearly it landed on a machine that didn't have this issue. So we do have results here, and we do feel confident that this is infrastructure problem. So we would mark that top level target is not a blocker. I do want to also note that if we have to force a rerun, as in the example here where we reran the automatic rerun was relatively successful on a particular machine, but there were still 2 test cases failing. We want to just rerun those 2 test cases. We had to kick off a grinder. A grinder job lets us run something. When we do that, when we kick off a grinder, the other thing that we do immediately from after running that grinder is download the tap file and attach it to the issue so that we have that on record, because the tap file collects the information about the test material that was used, the product under test, and the test cases that were run. So we have enough evidence to indicate that, yes, we were able to run this on a particular machine. It also includes the machine information in it, and we're good to proceed. Again, these errors that were happening in the previous runs indicate that it's likely a machine configuration issue. So eventually, after some automatic reruns completed and some manual reruns and grinders completed, we could mark this platform as ready to release. So just as a quick example of the tap files that get gathered and attached to the build pipeline, again, they represent the top level targets that were run that are part of the AQAvit verification. And at the moment, you can see that for extended OpenJDK, because that top level target is so large, we split it out into 3 and run it across 3 different machines in order to reduce the execution time and get done a little faster. But I just wanted to show what a tap file looks like. It includes information about the thing under test, and it also includes information about the test material and the SHAs that were used to, the exact test material that was used to test this. It gives you a quick summary across the top of the file, and really what I'm looking for here is that it says failed 0, as in no test targets failed. All of the test targets that are part of this top level target were run and passed successfully. And you can kind of go through each one of these to see, okay, let's see if we can find an example where there was a failed target, and it's likely going to be in one of these extended ones. Here's an example. One of the test targets failed of the total that were run, or 18 were executed, and the JDK security infra target in mode 0 actually failed, and it was a single test case out of the 10 that were run as part of that target that actually failed. So we can now dig in and understand that, and we can also rerun that particular test case rather than rerunning all of the tests within this target. And it reduces the amount of time it takes us to triage and understand the root cause of the problem when we can granularly only have to rerun test cases versus test targets versus top level targets. All right. I think that concludes really the main parts of the demo that I wanted to talk about today. The important bits are that we worked through each one of the platforms for each one of the triage items. We confirm that we're confident that all of the quality tests pass. We do the same type of activity on the compliance tests on a private repo under the Temurin compliance project. And then essentially we mark the status issue that's up in the Temurin repo as good to ship. So that's an indicator that if all the check marks are good to go on both AQAvit and Temurin compliance tests, then we're ready to publish a platform. Thanks very much for staying with this very long talk about AQAvit and Adoptium triage for releases. You're most certainly welcome to come and join the fun both during a release, but also as an activity in between releases for our EA pipelines, the early access pipelines that we run on a weekly basis. Hey, so after that demo, I hope you've picked up on the fact that we have some useful action buttons in that TRSS instance. Things that I use often would be deep history, possible issues, and create new issues. All platforms action button can be helpful if you're asking yourself the question, did this particular test target fail on all platforms? Or can I see that it's failing on all AR64 platforms or on all Linux platforms? It helps to get a view of how broad the failure is. Deep history is really heavily useful because it shows on a particular platform that test target and it's the history of it. This often reveals that there are infrastructure issues because you can start to see patterns that a particular test target always fails on a particular node and is passing on other nodes. So you can start to identify patterns there. Possible issues tells me as a triager that someone might have raised an issue about this thing already, and I can now feel free, if I identify that it does look like the same issue, I can add a note to it with some additional details that it's still happening and a link to the TRSS data that gives more information. If there isn't a possible issue that looks like it's describing the problem I'm seeing, I can click on the Create New Issue button and raise an issue with some of the information already pre-gathered for me. At the moment, I would still add console output manually to that issue and any other notes that I want that I think might be helpful, digging a little deeper into that. We don't go into detail during triage at this point because we're trying to, again, categorize and prioritize, but we do try to capture the issue at the moment that we see it because sometimes it's hard to go back. Often use the go directly to Jenkins job link as well to be able to see the JUnit output of the tests. Gives a good view of what's happening, and it might also be helpful And finally, there's also a rerun in Grinder link. This can also be found at the Jenkins job itself, but this is a quick loading of all the parameters that were used in the original run where a failure is seen. It loads it up and gets you ready to click the build button on the Grinder job in Jenkins. Sometimes you may need to change some of the parameters at this point, depending on what you want to run. You may want to add extra JVM options. If you're trying to debug something, you may want to modify what JDK you're testing, that kind of thing. Or you may want to specify that please run on a specific host. So you might change the label to be a host name and get a little further in your determination there. So for January, just for reference, we raise a triage issue for every version that we're triaging. And we did already look in the demo at a couple of these items to see that there's a table at the top of the issue so that we can collaborate with many triagers during a release and have a sense of order about who's looking at what and what's already been completed and the status of each item as we're going through a particular release. So some of the post-release actions as part of the triage activity really include that as we said, during a release triage activity, we're not stopping necessarily to try to figure out details about failures. In fact, sometimes we don't even raise an issue at that point. We put a note in the triage issue. So we have to come back and deliver on any actions for any of the notes we left ourselves. That's an important part. And kind of the last part of this is just making sure that we gather the TAP files, the test anywhere protocol files that we enforce that every test material that we're running creates. So we generate TAP files no matter what the underlying test framework is. And we create them in a certain pattern so that they're standardized across all of the types of, you notice the groups that we run testing on. For example, system tests don't produce JUnit output. So having the TAP files be generated by our testkit gen project is helpful to be able to represent those tests in the grid view and in TRSS. Everything is standardized to that very simple test anything protocol so that we can view things in a common way in our tooling. And gathering these TAP files and proving that we actually ran and passed all of the AQAvit quality tests is an actual requirement to be able to list in the Adoptium marketplace. All right, so the summary for this not so short lightning talk was that we covered some of the terminology and definitions used in the AQAvit project. We covered some of the basic navigation to the commonly used views in TRSS when you're doing triage. There's a lot of other views and features that we're working on to develop in the TRSS server, but today we looked at the basic ones. We looked at different actions that we can take based on triage findings. So looking at deep history to see if there's a pattern that shows some failures are only happening on a certain machine. We showed how we could rerun particular test case failures in a grinder. We showed how we can view and gather TAP files from those grinders. Updating triage issue, what is expected of triagers during a release for that item. And then we just talked about some of the post-release actions. So hopefully you can find this a little bit insightful, and it prompts you to want to come and help do triage either on our EA weekly triggered builds or even during a release. It's a very it's a race to finish quickly during a release, but it's kind of fun. So thanks very much.